block. That's good because you can make the guardians anybody. Like the guardians don't just have to be people you know. They can be other wallets that you own, like that you have to sign off on. And so it's like you can't send off all your crypto unless you have access to all 5 wallets that you own. That's a good solution. The above is a basic design and can be augmented. Session keys and permissions mechanisms like ERC 7715 and can help support different balances between convenience and security for different applications. More complicated Guardian architectures, such as having multiple time lock durations at different thresholds, can help maximize the chance of successful legitimate account recovery while minimizing the risk of theft. Who or what should the Guardians be? For an experienced crypto user who is inside a community of experienced crypto users, a viable option is the keys of your friends and family. Mm, But again, you can just like be the one that controls that. So it doesn't. So yes, it's a good idea. So if you ask each one to provide you with a fresh address, then no one needs to know who they are. In fact, your guardians don't even need to know who each other are. Exactly, and they don't just need to provide. You can just create those fresh addresses for yourself. But I understand where Vitalik is coming from with this. The chance that they will collude without one of them tipping you off is tiny. For most new users, however, this option is not available. A second option is institutional guardians. Firms that specialize in performing the service of only signing a transaction if they get some other confirmation that a request is coming from you. Example, a confirmation code. Brilliant. Literally taking the idea that we have right now in the real world and applying it in mass. Brilliant. And it's the simple things too. Or for high value users, a video call. Ooh, yes, yes, video call. Protect us from sending away our Ethereum in a malicious transaction. This is a good idea. Like the horror stories that I've heard, that would be perfect. People have attempted to make these for a long time. Example, I profiled Crypto Corp in 2013. However, so far, such firms have not been very successful. A third option is multiple personal devices. Example, phone, desktop, hardware, wallet. This is what I was thinking. This can work, but also is difficult to set up and manage for inexperienced users. There's also the risk of devices being lost or stolen at the same time. Oh, snap. I didn't even think of that. Yep, especially if they're at the same location. Oh, that's right. Recently, we have started to see more wallets based on passkeys. Passkeys can be backed up on your devices only, making them a type of personal device solution, or backed up in the cloud, making their security dependent on a complicated hybrid of password security, institutional, and trusted hardware assumptions. Realistically, passkeys are a valuable security gain for ordinary users, but they are alone and not strong enough to protect a user's life savings. Fortunately, with ZK Snarks, we have a fourth option, ZK wrapped uh, centralized ID. This genre includes ZK email, Anon Adhar, Mina Wallet, and many others. Basically, you can take many forms of crypto or government centralized ID and turn it into an Ethereum address, which you can only send transactions from by generating a ZK snark proving possession of the centralized ID. Your own devices, types of guardian, friends or family, or he just illustrated the picture, specialized guardian. For those of you who can't see, he has a picture of your own device and a bubble type of guardians, and then friends and family. And then he has specialized guardians, picture of a bank, and then ZK wrappers of existing services. Okay. So with this addition, we now have a wide array of options, and ZK Wrap centralized ID is uniquely noob friendly. For this to work, it needs to be implemented with a streamlined and integrated user interface. You should be able to just specify that you want example@gmail.com as a guardian, and it should automatically generate the corresponding ZK email Ethereum address under the hood. Advanced users should be able to enter their email, along with perhaps a salt value for privacy that would be saved in that email, into an open source third party application and confirm that the address generated is correct. That the same should be true for any other supported Guardian type. So this is a mock-up of a possible safe interface. So signers and confirmations. So set the signer wallets of your safe account and how many you need to confirm to execute a valid transaction. So you have the signer name, so you can have like multiple signers, and then the signer's Ethereum address, something like this. But how does it work in? practice. Note that today, one practical challenge with ZK email specifically is that it depends on DKIM signatures, which uses keys that are rotated once every few months, and these keys are not themselves signed by any other authority. This means that ZK email today has some level of trust requirement beyond the provider themselves. This can be reduced if ZK email used TLS notary inside trusted hardware to verify updated keys, but it's not ideal. Hopefully, email providers will start signing their DK keys directly. Today, I would recommend using ZK email for one guardian, but not for a majority of your guardians. Do not store funds in a setup where ZK email breaking means that you lose access to your funds. New users and in-app wallets. New users realistically will not want to have to enter a large number of guardians in their first sign-up experience. Hence, wallets should offer. I'm so hungry right now, but I'm gonna keep going. So for you all, and for myself too, because I want to learn. So hence, wallets should offer them a very simple solution. One natural route is a 2 of 3 using ZK email on their email address. A key stored locally on the user's device, which could be a passkey, and a backup key held by the provider. As a user becomes more experienced or accrues more assets, at some point they should be prompted to add more guardians. Wallets integrated in applications are inevitable. Because applications trying to appeal to non-crypto users do not want the confusing user experience of asking their users to download 2 new applications, the app itself plus an Ethereum wallet at the same time. However, a user of many application wallets should be able to link all of their wallets together so that they only have one access control thing to worry about. The simplest way to do this is a hierarchical scheme where there is a fast linking process that allows the user to set their primary wallet to be the guardian of all their in-app wallets. The Farcaster client Warpcast supports this already. Okay. By default, your Warpcast account's recovery is controlled by the Warpcast team. However, you can take sovereignty over your Farcaster account and change the recovery to your own address. All right. Protecting users from scams and other external threats. In addition to account security, wallets today do a lot to identity fake addresses, phishing, scams, and other external threats, and try to protect their users from such threats. At the same time, many of the countermeasures are still quite primitive. For example, requiring a click-through to send Ethereum or any other token to a new address, regardless of whether you're sending $100 or that 100,000. Here, there is no single magic bullet solution. It's a series of slow, ongoing fixes and improvements to different categories of threats. However, there is a lot of value in continuing to do the hard work to improve here. Privacy. Now is the time to start taking privacy on Ethereum much more seriously. ZK Snark technology is now very advanced. Privacy technologies that mitigate regulatory risk without relying on backdoors, such as privacy pools, are growing more mature, and secondary infrastructure like Waku and ERC-4337 mempools is slowly becoming more stable. However, up until now, making private transfers on Ethereum has required users to explicitly download and use a privacy wallet, such as Railway or Umbra for stealth addresses. This adds great inconvenience and reduces the number of people who are willing to make private transfers. The solution is that private transfers need to be integrated directly into wallets. A simple implementation is as follows. A wallet could store some portion of a user's assets as a private balance in a privacy pool. When a user makes a transfer, it would automatically withdraw from the privacy pool first. If a user needs to receive funds, the wallet could automatically generate a stealth address. Additionally, a wallet could automatically generate a new address for each application that a user participates in. Example, a DeFi protocol. Deposits would come from the privacy pool and withdrawals would go straight into the privacy pool. This allows users' activity in any one application to be unlinked from the activity in other applications.